This is section 3.5. And we're going to be talking about the fundamental theorem of algebra. Ultimately, what we're going to do here is we're going to combine real and complex roots. We're going to find how to find both of them. Okay, so fundamental theorem of algebra, let's take a look at it real big, says that the number of zeros equals the highest power you've got, which you'd remember as being the degree of your polynomial. So let's take a look at an example. We go in, the highest power is 5. So what this means is I have 5 zeros. And they can be either real or complex. This doesn't tell me what I've got, it only tells me that I have 5 total. Now, one thing to keep in mind, when you have something like this, where I have a polynomial with real valued coefficients. And all of my coefficients are real valued on this polynomial. What that means is that my complex roots occur as conjugate pairs. So what this means is that if you find 1, which is 1 plus 3i, its conjugate is 1 minus 3i. And both of these will be zeros of the polynomial if it has real valued coefficients, which are the only ones we're going to deal with. All right, so let's work through some examples here. The first one is we want to find all zeros and then write in factored form. So the polynomial we're going to be given is x to the 4th plus 4x squared. Okay, well, the first thing I would do is to factor this out, and I can pull an x squared out. It's going to be x squared times x squared plus 4. And if I want to find zeros, I set it equal to 0. Okay, so my first zero then is going to be x equals 0, and it's going to occur twice. So I've got a repeated root, and the square tells me it occurs twice. So now I've got to set this equal to 0. Okay, because I don't have an x term, I'm going to do this. And then take the square root, so I'm going to have x equals the square root of negative 4, which is going to be I times the square root of 4, which is going to be plus and minus 2i. So there are my other two roots, plus or minus 2i, and then I have x equals 0, and it occurs twice. So to write this in factored form, I'm going to write this as x squared, and then I'm going to have x plus 2i, which is from the minus 2i, and x minus 2i. And that's the factored form of this polynomial. Let's work another one. X to the fourth minus 16. Okay, now I recognize this, and at this point you should too, as a difference of two squares. So this will come out as being x squared plus 4, x squared minus 4, with this being the square root of this being the square root of this. Because it's a 0, I set it equal to 0. So the first thing I'm going to do is solve this guy. I have x squared plus 4 equals 0. This should look familiar. X squared equals negative 4. X equals plus and minus 2i. And I solve this one. X squared minus 4. X squared equals 4. Or x equals plus and minus 2. And there are my 4 roots. I know I've got 4 because my power is 4. So I've got 2 complex and 2 real. And now I want to write this in factored form. And it doesn't really matter what order you put them in, just as long as you put them in some kind of order. I tend to put my reals first, but you don't have to. So I'll have x plus 2, x minus 2, x plus 2i, x minus 2i. And this is the factored form of this polynomial. Okay, let's take a look at another one. This is my polynomial. And again, I want to factor it and bring it back in. Now, one way you can do this is to use a rational root theorem. So we know that 9, which will be my p, will be plus or minus 1, plus or minus 3, plus or minus 9. And I've got a 1 out here. So my possible roots are going to be p over q, so they're going to be plus or minus 1, plus or minus 3, and plus or minus 9. And then I could go in and do my synthetic on each one of these. I would probably want to start with plus or minus 1. So let's do that. Let's check out the minus 1 for plus 1 first. So I'm going to have 1. And then I'm going to have 1, 1, 9, 9. Notice I'm not missing any terms. So do synthetic, you bring the 1 down. 1 times 1 is 1, add them. 1 times 2 is 2, add them. Okay, because I had a non-zero remainder, what that tells me is that plus 1 is not a 0. So the next one I'm going to try then would be negative 1. And again, I'm going to use synthetic. So I'm going to have negative 1. I'm going to bring that into 1, 1, 9, 9. Bring the 1 down. 1 times 1 is a negative 1. That gets me a 0. That gives me a 9. So what that means is that x equals negative 1, because that's a 0, is a 0. And what I'm left with now is x squared plus 9 equals 0. Okay, and this one we can come back in. Now that we're at a quadratic, we could solve it. So that x squared equals negative 9, or x equals plus and minus 3i. So that's one of my zeros. There's my other two. If you remember, I started out with a quadratic, so there are both of my zeros right there, all three of my zeros right there. Let's start out with a cubic, excuse me, third order. So now we need to write this in factored form. So, well, my zeros then are going to be x equals negative 1 and x equals plus and minus 3i. And to factor this guy, it's going to be x plus 1, which will make that 0. Then I'll have x plus 3i and x minus 3i. And that's this one. Okay, now, we could also have done the same thing, but using grouping with this one. This shows you how to get it with rational root. But let's go in and do this thing using grouping. So p of x is x cubed plus x squared plus 9x plus 9. So I'm going to group these together, and then I will group those together. So I'm going to factor x squared out, and that will leave me with an x plus 1. And then I'm going to factor a 9 out, which will leave me with an x plus 1. And you'll notice this term is common to both of them. So p of x now will be equal to x plus 1. I'm going to factor that out. All I'm left with out of this term will be x squared plus, and what I'm left with out of this term is 9. So the ones I solve would be x plus 1 equals 0, or x equals negative 1, and then x squared plus 9 equals 0, x squared equals negative 9, or x equals plus and minus 3i. Now you can see this is a whole lot less work once you did the grouping, and it's usually a good thing to try. Grouping doesn't always work. In this case, I could see that it did. Just from experience, I could see I had x cubed and x squared, and then I had 2 9s back over here. So my coefficients were the same, and I had something over here, and I could factor an x squared out. So I knew this was a good candidate. It's usually not a bad thing to at least try it once, see if it works. If it doesn't, then you need to go back, and if grouping doesn't work, then you're going to have to come back over to our old friend over here, which is your rational root theorem and synthetic division. So the last skill you're going to need is finding a polynomial with integer coefficients. And they're going to give you something like p has degree equal 2, which means it's a quadratic, the highest power you have. And you have zeros of 1 plus I, and since it has real zeros, the conjugate is also going to exist. So 1 minus I. So we need to find this thing. Okay, well, here are your factors. So we're going to do P equals x minus 1 plus I times x minus 1 minus I. The first thing I'm going to do then is distribute this in. So P will be x minus 1 minus I, and this will be x minus 1 plus I. Okay, now to come back in and work this guy, we're going to have to distribute. So the first thing we're going to do is take my x and take it to all three terms over here. So that will give me x times x is x squared, minus 1 times x is x, plus I x. So that's from the first one. Then I'm going to take my negative 1 and distribute it. That will give me minus x minus 1 times minus 1 gives me a plus 1. And then minus I plus I gives me minus I squared. There's my second group. And then I take my I and distribute it into here. And so that will give me minus ix plus I, negative I times negative 1 gives me a plus I, and then, oh, I made a mistake here, that should just be not minus I squared, I should have negative 1 times, so it should be a minus I up here. So I've got minus I and then minus I squared. Alright, so what I'm going to do now then is come back in and start looking for terms which cancel out. You notice I've got a plus ix and a minus ix. I'm specifically looking for those because since this says real valued, all my i's should go away, and those do go away. And then up here, I've got a minus I here and a plus I here. So those go away. And it should recognize I squared as being minus 1. So this thing right here changes into a plus 1. And now I gather all my terms. So I've got an x squared from here. Minus x gives me minus 2x. And then I'm going to have a plus 1 from here and a plus 1 from the minus I squared, which will be plus 2. And there is the polynomials, your polynomial, and you notice it has all real valued coefficients. So that's how you do that. And that's what the homework is going to be on section 3.5.